This is the first lesson in how to use the Raspberry Pi, the SpectraCyber software. I've already started the Raspberry Pi by clicking on this icon. And when it comes up, you get your main screen. We have a file. We have a menu here that has the file, commander, plot, function, fit, web, tools, and so on, and setup. Everything. We're going to assume the setup's already been done. Basically, we've added in the location of your observatory, where we've entered the latitude and longitude and other information that's optional, but it's important to have it. So let's go ahead and start. The first operation would be to begin the commander. We're going to start up the commander here, and it brings up a second window. These windows can be dragged and dropped and placed anywhere. I've currently got it set up to do a frequency scan here. We have it set for continuum. Let's turn it to spectral. And I'm going to, because it's a spectral, I'm going to have to lower this down a little bit here. Let's bring it down to about, let's take it at 13 dB and see what we get. Now before we start, we want to be able to check and see if the antennas are lined up and if we're not going to drive ourselves into saturation and go over scale here. So let's click on the antenna. It'll take a moment or two. By the way, while it's coming up, this Raspberry Pi is actually operating at a good distance away, and it's being operated through my Linux computer using the VNC software. So this is what it would look like if I was sitting directly in front of the screen, but I'm actually controlling this from 200 feet away. You can see that the amplitude is quite high here. It's probably going to be a little too high. We need to change that. So let's close this down. Come back here and let's drop this down a couple of dB. We'll bring it down to 12 dB. Let's see what that does. Realign the antenna. Take another look at it here in a second and see if we got something around the mid-range. This probably might be okay. Let's hope that it will be. It's a little high, but it might work out. Okay. So we're going to do a rather short scan from 200, minus 200 to plus 200. Integration time of 0.2 of a second, and that's what's set on my Raspberry, on my SpectracyberPi 2 out there. That's a manual switch, so all this is recording data on a Cyber 1. Of course, there would be different choices, and they are important, and so on. You have a gain of 10 over here, which is artificial for the SpectraCyber 2, but on the SpectraCyber 1, that's a real number. Your settings, of course, will be different, and there's an offset and so on. We have it set for 4 hours. We don't want to do 4 hours here. We're just going to turn off the timer. We don't need it because it'll stop at the scan rate. And we're going to start the scanner. I'm going to choose the scanner and choose a live scan so we can actually watch it run. Now while that's coming up, it should begin on its own here. We'll see a graph here shortly. Let's put this over here. We could have, of course, arbitrarily gone over here and clicked the scan button, which would have turned it to a stop button like we have. And that would have stored the data in the background mode, and you would not be seeing this chart. If you want to actually watch the chart, you need to do this and let it run, and you can stop it in two ways. It says up here you can either click the X button to stop it, or you can click over here on the stop button, on the red stop button. The buttons will change color accordingly, and they'll be enabled or disabled as needed. Now you can see we're picking up some signal here, and as this builds up, we'll just watch and see how this goes, and we should see, hopefully, we may not see a rise. I don't know if we're anywhere near the galactic plane. We might see something here, but let's take a quick look. Up here, we're running K-star. So while that's running, let's bring up the K-star screen and see where we are. It claims we're in an area that's pretty much empty. Middle of the screen, if you look down here, look in the bottom right hand corner, shows it about around 16 hours. Let's see what time we actually have. So let's minimize this screen again and come back here, take a look at the sidereal time. We're at 15 hours. 15 hours in 50 minutes. You see it's ticking away. You notice now that it may not be ticking at an exact increment of numbers. That's because of software latency. It is running accurately. It will correctly record the time of each point. But based upon your integration, based upon any delays you might have put in, and the software delay, this graph showing up, it will appear to run kind of funny up here. Notice we just jumped by 3 seconds, and we jumped by another 2. This is artificial, but it's not really happening. What's really taking place is a true reading. And it looks pretty much like we're not going to... Wait a minute. Let's see if we're going to get any rise here. No. Since we're not anywhere near any nebulosity, any hydrogen gas, we're probably not going to get any kind of a peak here. This is just going to be the random noise in the background. But this gives you a rough idea of how this thing works. Now, it's nice to use this scanner, but when the scanner's done, the file is not actually saved. The file will automatically be saved in a file called the temp file, which is listed in the SpectraCyber directory as temp.csv. You can load this file into the spreadsheet program, which you can find up here. Going down into the Office. Where's Office? Right here. In Office, you could load it up into LibreCalc if you wish. There we see something, a response down here. There's a response. So whatever gas we're seeing has been pretty much shifted to the positive range. That's a definite rise. You can see that it's certainly gone up. And as we come to a close, this will ask us to click OK if we're done. But if we do that, this will terminate rather quickly here. So if it does, it'll disappear, but it can still be replotted. Now let's do that. Let's go ahead and click this off. We just would like to take a look at this again, so we can plot it right here. You can also plot from over here, but it's better to plot from here for right now because we just took the data. This is going to bring up the temp file, and there we see what the temp file looks like. Now you notice at the end there's not a whole lot, but it occurred at around 15 hours in something. So if we put the cursor right about here, you can see it's 15.8641 hours on the x-axis, a sidereal time. You could determine that sidereal time. Now to show you what we can do with this, of course, we can come down here and we can zoom a rectangle. So let's choose a rectangle right around this region. And we zoomed in a little bit. Now of course you could do this and expand it several times if you wish. And you can get some information and some nice display on that. But you notice it's not a great rise because we didn't really have a whole lot of gas in that region. Now the other thing we can do is we can come back over here and we can plot from this side if you wish. Let's do a sidereal plot. Let's take a look at what the temp CSV file, that's what we stored over here from our scan. Let's open it up. We open it up, there it is again. You can see that, but now we see it in sidereal time. And you can see that it's rather small. Once again, we can zoom it. And to zoom it, we just come down in here like this. Let's see if I can zoom this correctly. And it's going to be a little hard. This is close to the edge. Alright. It's not that important because what's really much nicer to do is go to the function fit. And in the function fit, we're going to select the temp file again. And here is where it begins to get interesting. It's preset to choose a Gaussian function, but you can, of course, choose any of these functions you wish. You can also add a baseline. The baseline will be actually a straight linear line here, linear, but it will try to smooth out some of the readings that could be erratic on the bottom. If we had a polynomial, we could pick the order. It's preset to do 3, between 3 and 7. And the type of fit would either be a frequency, universal time, or sidereal. Let's take a sidereal time. Do a sidereal time and click OK. And we'll see what happens. Okay, they bring up a small chart here, and we want to take a region. The region of interest is right here, so let's try to click at the beginning. We want to take a beginning spot, puts a little red dot there, and then we're going to choose the end coordinate, and when we click on it, it's going to take a moment, but what it's going to do is, between those two areas, this will display later. It has performed a fit, a Gaussian fit. And it has done this multiple times, manipulating the various parameters of the Gaussian fit in order to get the best chi-squared, the least squares fit using a chi-square. You can see the chi-squared is very low. It's a very, very good fit here. It's done 37 evaluations, calculating against 12 data points on this region. And it's used 5 different variables, optimizing those variables. And here are the variables, each one of them. And it gives us some information on the center of the signal and so on, and its amplitudes and the sigma value and so on, and the best fit, and giving us some arc lengths on here. It has actually gone over the scale, but that's okay. Let's see if we can minimize this a little bit. That's going to be too big. Let's see if we can have to get up here. Okay, let's see if we can shorten it and bring it up so we can see it a little bit. There we go. We want to click on the OK button, and that'll clear it. And now we get the final fit here. Here's the equation, and here's where the data has been calculated. See, we got our last point. We didn't quite get this last point. Gives us our integrated area underneath this curve. And the smooth fit, the green line, is the Gaussian smoothed out, telling us that that region happens to be about 2.3 arc minutes at its half-wave points. That's what it really is doing. It's giving us the sigma amplitudes, and the smooth fit here. The peak of the curve is about 15 hours, 51 minutes, and 45 seconds. So you could go to stars and put yourself, if you look at the bottom, in 15 hours. What was it? We said about 47 minutes, 51 minutes, and 47 seconds. That's the center of where we were, right there in the middle of Coriolis Borealis. Nothing there of interest, but maybe a little bit of gas at that point. Anyhow, there we have it. And of course, if there's a Doppler shift, it will give us the values for the Doppler shift, and we are on a particular range here. It's well on the positive side. You can see that the center's way over here. But anyhow, that is basically what we get. And if we wanted to save this information, of course, we can save the plot under a different name. Yeah, it's optional. We don't really have to, but if you don't do this, the next scan you take, things will actually disappear. So that's a brief introduction. There's a lot more to learn, different ways of setting things up. You can run in project modes. You can create a brand new project here. You can then open that project. You can select projects from the project table down here, and if you do, it'll switch to the various project sessions, and you can operate different sessions. It will automatically preset all of your values to whatever settings you were using the last time. And on a project mode. On a manual mode, you'll be completely free to change all these things yourself. But in a project mode, you should leave them alone, because it's putting the experiment back exactly the same way it was when you ran it previously. So if you're running an experiment over a period of time, it's best to run a project mode, picking your object and so on. We'll learn more about this in lesson 2. So that's it. I hope you enjoyed your lesson.